Section 5.5, indirect proof. What we're going to do is use indirect reasoning to write proofs. This is not a two-column proof. It's something totally different than that. It's kind of like a backwards style proof. There are 3 steps to it, and I'll tell you what the 3 steps are, either today or tomorrow, depending on what we have time for. It's assuming something you know is false already and kind of showing it that way. So it's kind of a different way of looking at things. Indirect reasoning is all possibilities are considered and then all but one are proved false. The remaining possibility must be true. An indirect proof is a statement and its negation are the only possibilities. When you see that one of the possibilities leads to a conclusion that contradicts itself, you can eliminate that possibility, and then the original one must be true. And it's also called proof by contradiction. Here are the steps. You might want to write these down. Get them on the same page. Number 1, state the negation of what you want to prove. We're going to go through that today. So that's the easiest part right there, step number 1. Step number 2 is the hardest part. Show that the temporary assumption leads to a contradiction. We're going to stick to kind of more of the basic middle step ones. There's lots of them that I could use, and there's lots of them that are by far more geometric than what you guys want to probably go. I'm going to stick to more basic proofs that kind of are, here's step 1, here's step 2, here's step 3, and I'm done. And then step 3, you have to write a little conclusion that tells why you contradicted what you said and that the original must be true. And there's different ways to write those as well. I like to stick to one specific way, but if you read in the book and you like another way better, that's totally fine. So 3 different steps to writing an indirect proof. Okay, so let's just look at step 1 for a minute. Problem 1, suppose you want to write an indirect proof of each statement. As the first step of the proof, what would you assume? So looking at what you guys just wrote down, the first step said, state the negation of what you want to prove. Negation just means the opposite. So if you look at this one, an integer n is divisible by 5, the opposite would be an integer n is not divisible by 5. So it's super easy to change it to what it isn't. You're just going to do the opposite. Sometimes you add a word, sometimes you have to add a little phrase in there, but you want it to make sense. So here is my assumption. Assume an integer n is not divisible by 5. So whatever it says, you're going to do the opposite. And it always usually starts with assume because you're assuming something that wasn't already stated. Okay, what should we write for the second one? You do not have soccer practice today. So assume what? That you do have soccer practice today. And you do have to use words. You have to use the words. Don't be skimpy with the words. So assume you do have soccer practice today. Okay, step 1, pretty easy. Should be. Okay, step 1 is one that generally students do get right because it is straightforward. You just assume the opposite. Okay, here's a got it question. Let's try this one as well. Again, what would you assume in the first step of an indirect proof? So triangle BOX is not acute. How would you restate that one? Okay, so triangle BOX is acute. And so assume triangle BOX is. Make sure that you don't change the words. Like if I had assume triangle BOX is acute for the first one, you don't want to say triangle BOX is obtuse because aren't there other kinds of triangles besides obtuse? If it's not acute, you have to include everything else. So the easiest way to do these is just state the opposite. Don't change words, just make it the opposite. So you don't want to change it to something else because then you have to include everything else. And if you don't remember there's everything else, then you get it wrong. Okay, so it isn't acute, so the opposite it is. Make it simple. This one's worded a little bit different. At least one pair. So at least one pair of shoes you bought cost more than $25. There's different ways that you can write this one. If we keep to the assume that at least one pair is, what do I need to change the rest of it to? Yep, assume it doesn't cost more than 25 or it's less than or equal to 25, right? Because more than 25 would not include 25, but the opposite of that would be less than or equal to 25. So assume at least one pair of shoes you bought cost less than or equal to $25. You can use symbols if you want to when you get to some of these things. If you did cost less than 25, you probably wouldn't get full credit because more than 25 and less than or equal to 25 includes everything. If you forgot the equal to part, it doesn't include everything. It only includes part of that, part of it. Okay. So the next part, to write an indirect proof, you need to be able to identify that there's a contradiction. This part gets kind of tricky depending on the style of proof that they write. We're just going to go through statements and we're going to try to see where the contradiction is. So it's not actually writing the proof yet. We'll probably write those tomorrow. Which two statements contradict each other? Basically, which two statements are kind of like the opposite of each other? We have FG is parallel to KL, and those are segments. We have segment FG congruent to segment KL, and we have segment FG perpendicular to KL. Which two are kind of opposites of each other?
FG is parallel to KL and FG is perpendicular to KL.
Because can they be parallel and perpendicular at the same time?
No.
No. So that's kind of what you're looking for. Could they be congruent and parallel at the same time?
Yeah.
They can. Could they be congruent and perpendicular at the same time?
Yeah.
Yes. It's the ones that cannot be possible at the same time. So the two that are contradicting are parallel and perpendicular. And that's kind of what you're looking for is, can they be these two at the same time? If your answer is no, you have found the statements that you want. Okay, so that's a contradiction. Here's a got it question. ABC is acute, and these are triangles. ABC is scalene, and ABC is equiangular. So in order to do this one, you got to know what each of the words mean. Okay, acute means what? Okay, all the angles are less than 90. What is scalene?
Each angle is a different measure.
Yep, each angle is different. So you could have like a 30, a 50, and a 20, whatever. They're all going to be different. What's equiangular?
All angles are the same measure.
All angles are the same. So which two cannot be at the same time?
You cannot have an equiangular scaling triangle.
Right. So equiangular means they're all the same. Scalene means they're all different, and you can't have all the same and all different at the same time. Okay, so it's 2 and 3. It could be acute and scalene. It could be acute and equiangular because it is, but you can't have 2 and 3 at the same time. Okay, so I think I'm going to stop right there. We have about 10 minutes left. We're going to start tomorrow with how do you write these proofs when we're dealing with how do you write the first step, how do you write the second step, and then how do you conclude it. I think we're going to run out of time even if I get into one, so I want you to start the assignment, and when we get to those proofs, we're just going to stop. Okay, so I'm going to give you the assignment, but I only want you to do the ones that we've done today, and then we'll start right here tomorrow.